Hey guys, welcome again to the Maths Club. If you're just joining us, welcome. In this particular video, we're looking at WAEC past questions on length and perimeter from 2014 to 2023. So in this one, we're looking at length of circles and perimeter of circles. If you're just joining us, please hit the subscribe button, and if you're a returning viewer, welcome again. If you go on to like the video, please drop a like on the video, and if you have any question or any comments or contribution at all, drop in the comment section. I will address all of them. Let's get started. First question is taken from June 2014, and it says a chord 7 cm long is drawn in a circle with radius 3.7 cm. Calculate the distance of the chord from the center of the circle, and it's taken from June 2014. If you've been following any of the videos we've done prior to this, you will see that you'll be able to solve questions like this. So I will encourage you to pause the video and try it out yourself. Welcome back. Let's solve it together. So we have this our circle, and these 2 points, let me point it out, these are our radius and these are our radius. This point 0. So it says a chord 7 cm long, so we need to draw a chord, right? We've talked about all of these things, what the chord is and all of those things. So this is the chord. Let's say this is the 7 cm long chord, and it's drawn with the radius of 3.7. so that means this one here is 3.7, so r is equal to 3.7. So it now says that we should calculate the distance of the chord from the center of the circle. This is the center of the circle, this is the chord. The length we're trying to find is this perpendicular distance. So they're telling us that what is the perpendicular distance from the center of the circle to the chord. That's basically what they're asking. And if you look at this, this is 3.7, 3.7, and this will form a right angle triangle. So if I say this like a right angle triangle, one thing you need to notice is that this perpendicular line, it bisects this line into 2 equal halves, meaning that this place will be 3.5 centimeters, place of 3.5 centimeters, because the total length is 7, and in this line it divides this entire line into 2. So if I'm looking for this height here, I'm looking for this h, this one here, this h, let's say this is the h. If I bring it out, so let's just say that this is this part, this half of the triangle. This place here is our 90 degrees, so this here is our right angle. This radius is 3.7 centimeter, and this length here is half of the entire length, which is 7 divided by 2, which is 3.5 centimeter. And we're looking for this h. So this is a right angle triangle, and we did Pythagoras theorem. We said from Pythagoras theorem, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. The hypotenuse here is 3.7, so that will be 3.7 squared is equal to the opposite here. You know, this is our angle theta basically, right? The opposite here is h, so that is h squared plus the adjacent is 3.5, so 3.5 squared. So that will be h squared will be equal to 3.7 squared minus 3.5 all squared. So my h squared will be equal to, I'll just punch that into my calculator, 3.7 squared minus 3.5 squared. That gives me 1.44. So my h would be square root of 1.44. So I'll just say taking square roots of both sides, right? You have to be explicit what I'm doing. This is a theory question. So the h would be, if I take the square root of that, that will give me 1.2 centimeters. So this h here is the distance of the chord from the center of the circle. If you got it, well done to you. Let's see if our answer is correct. So that would be option B. Great. Question 2 now says that a chord subtends an angle of 120 degrees at the center of a circle of radius 3.5 centimeters. It says you find the perimeter of the minor sector containing the chord, and we should take pi to be 22/7. This is taken from June 2014. Once again, I will encourage you to pause the video and try it out yourself. Welcome back. Let's solve it together. So these are our chord. If any of all these things is looking strange to you, please watch the videos before this where we talked extensively on shapes of a circle and all those things, and also calculate the length and perimeter and all that. So the chord subtends an angle of 120 degrees. So this place here is the 120 degrees. Of course, this is looking similar than 120 degrees, but that's fine. The radius is 3.5 centimeters, so this r here is 3.5 centimeter, and this is also r, right? So that says find the perimeter of the minor sector. This is the minor sector, this guy here, and this is the major sector. So it now says that we should find the perimeter of the minor sector containing the chord, and we should take pi to be 22/7. So for the perimeter, we have this, and this. So if you look at it, that would be P will be equal to r plus the length of the arc, and that would be 2r plus length of arc is theta over 360 times 2 pi r. We've established that in the previous video. So that would be 2 times 3.5 plus 120 over 360 times 2 times 22/7 times 0.5. This here 1, this here 3. So this is not 0.5, this is actually 3.5, my bad. So 3.5, so 7 here 1, 7 here 0.5. So 2 times 3.5 is 7, so 7 plus, let me do this will be 2 times 22 times 0.5 divided by 3, so this is 7.33. If I had both of them together, that will give me 14.33. Let me just say two decimal places. I don't know the decimal place they put in the option, but 14.33 centimeter is important to put a unit to 2 decimal places. Let's see if we're correct. So that will be option A. Great. Question 3 now says that a sector of a circle with radius 6 centimeter subtends an angle of 60 degrees at the center. We should calculate the perimeter in terms of pi. This thing from June 2015. I also pause the video and try this out yourself. Welcome back. Let's solve it together. So we're told that a sector, these are sector, radius, the r, this is r, the area is 6 centimeter. We're told that it's also an angle of 60 degrees, so this place says 60 degrees. At the center, calculate the perimeter in terms of pi. So we know that P is equal to r plus L, like we established, this will be 2r plus theta over 360 times 2 pi r. So if I substitute, that will be 2 times 6 plus 60 over 360 times 2 times pi times 6, right? So 60 here 1, 60 here 6, 6 comes to 6. So 2 times 6 is 12 plus 2 pi. Let's see, probably they factored out 2. So this will be 2 open bracket 6 plus pi, right? So any of all these 2 would do. Let's see if we are correct. Okay, so our answer is option A. They just swapped positions. Addition is commutative, so 2 plus 3 seems as 3 plus 2. So we are good. So A is our answer. Great. Question 4 states that in a circle radius r centimeter, a chord 16√3 centimeter long is 10 centimeter from the center of the circle. Find, correct to the nearest centimeter, the value of r. This is taken from June 2015. I want you to pause the video and try this out yourself. Welcome back. Let's solve it together. So the radius here is r. This is r. The chord here is 16√3. So it's 10 centimeter from the center. Great. And correct to the nearest centimeter, the value of r. So to solve this, same thing too. I'll just take one part of the triangle. So let me just take this side here. This is 90 degrees, right? Because this place is 90 degrees, this place is 90 degrees. This height here is 10 centimeters, so this 10 centimeter. This length here, the full length is 16√3, but half of it is 8√3, right? And this place here represents our r. So we could say from Pythagoras, the hypotenuse squared is equal to the opposite squared plus adjacent squared. The hypotenuse is r, so that will be r squared. The opposite is, this is our theta normally. This will be 10 squared plus, okay, this must be centimeter, plus the adjacent is 8√3 all squared. So this is 100 plus 8√3 all squared. If you do that, that will give you 192. So if you had this will give you 292. So our r squared is equal to 292. So if I take the square root of both sides, That will be r is equal to square root of 292. My r is 17 points, let me just say 0.9 centimeter. But the question said that we should find it and correct it to the nearest centimeter. So to the nearest centimeter, that will be r will just be equal to 17 centimeter to the nearest centimeter. Nearest centimeter is like saying nearest whole number. Let's see if we're correct. That will be option B. Great. Question 5 says that the perimeter of a sector of a circle of radius 21 centimeter is 64 centimeter. We should find the angle of the sector and should take pi to be 20/7. This take from June 2016. I want to pause the video and try that yourself. Welcome back. Let's solve it together. So these are sector here 1, 2, and 3. This is the radius, this is the radius, and this 21 centimeter. We're told to find the angle, so this is theta. We know that the perimeter is going to be 2r plus L. We've established that, which is 2r plus theta over 360 times 2 pi r. So let's substitute. The p is given as 64. 2 times the r is 21 plus theta over 360 times 2 times 22 over 7 times r, which is 21. So 7 here 1, 7 here 3, 3 here 1, 3 here 120, 2 here 1, 2 here 60, 2 here 11, 2 here 30. So that will be 64 is equal to 2 times 21 is 42 plus 11 theta all over 30. So if I collect like that, so that's 64 minus 42 is equal to 11 theta over 30. 64 minus 42, that will give me 22. So that's 22 is equal to 11 theta all over 30. And if I cross multiply, that will be 22 times 30 is equal to 11 theta. And if I divide both sides by 11, 11 here cancel this will give you 2, 11 cancel this, so our theta will be 2 times 30, which is 60 degrees. So our answer here is 60 degrees. Let's see if we're correct. That will be option B. Great. So question 6 now says that in the diagram, MN is the chord of a circle KMN, which has a center O and radius 10 centimeter. If the angle MON is 140 degrees, find and correct to the nearest centimeter the length of the chord MN. This take from June 2016. I want to pause the video and try that yourself. Welcome back. Let's solve it together. So MN is the chord, KMN is the circle, and the radius is 10 centimeter. You should find the length of the chord. So what's the formula for length of chord? Who can remember? Great. Well done. So that will be 2r sine theta over 2. We established that in the previous video to this. So that will be 2 times our r here is 10 times sine our theta here is 140 all over 2. So that will be 20 times sine 70. So our length of chord will now be equal to, if you point that to your calculator, that will give you 18.793 centimeter. But it says we should correct it to the nearest centimeter. So this would be approximately what? 19 centimeter. Simple and short. Let's see if our answer is correct. So if you look at the options, that will be option A. Great. Question 7 now says that a chord 20 centimeter long is 12 centimeter from the center of the circle. Calculate, correct to 1 decimal place, the angle subtended by the chord at the center of the circle. And we're told that we should find the perimeter of the minor segment cut off by the chord. Take pi to be 3.142, and this from June 2017. Pause the video and try that yourself. Welcome back. Let's look at it together. So imagine these are circle and all this information that we were given are represented here. That means that this guy here is 20 centimeter, and this height, because it's 12 centimeter from the center, this will be 12 centimeter. This perpendicular line here. We're told to find the theta, right? So this, let me just say this theta. So if I take 1 half of this guy, so this 1 half. Remember, this line is bisecting the line into 2, and it's also bisecting this angle into 2 equal halves. So if this place here will be theta over 2, Abi, this place here will be half, which is 10 centimeter, and this height here is 12 centimeter. So this is opposite and this adjacent. So we know from our SOHCAHTOA, right? We've talked about this when we're discussing the video on lengths, right? So from the SOHCAHTOA, we know that this is opposite the angle and this is adjacent to the angle, so that will be tan. So we could say tan theta over 2 is equal to, the opposite is 10, that will be 10 over 12. So theta over 2, if you want to find the angle, that will be tan inverse of 10 over 12. So theta over 2 will be equal to, by the time you find the tan inverse of 10 over 12, what would that give you? That gave me 39.8. So because I didn't need to one decimal place, so I could just say 39.8, right? So if I cross multiply, my theta would just be what? If I multiply this by 2, this will give me 79.6. So my theta is 79.6 degrees. Now that we know that, it now says that we should find the perimeter of the minor segments. Remember, segment, not sector. So this is segments here. This is the minor segments here. The chord plus the length of the arc. So that means the perimeter P is the length of chord plus length of arc. So we know the length of chord to be 20 plus, but we don't know what the length of arc is. So find the length of arc, we'll just say theta over 360 times 2 pi r. So for us to find this, we need to find the r first. So to find r, I could just use this guy here, right? I could just say from this guy, we know that from Pythagoras, the hypotenuse squared is equal to the opposite squared plus the adjacent squared. The hypotenuse here is the r, right? Because if I just take one part here, this is 10, this is 12, this is the radius. So that would be r squared is equal to 10 squared plus 12 squared. So r squared will be equal to 100 plus 144, and r squared will be equal to 244. So our r will be equal to square root of 244, and you find square root of 244, what will that give you? That will give you 15.6. So our r is 15.6 centimeter. So now that we have the r, we can now substitute and say this will be 20 plus our theta here is 79.6 all over 360 times 2 times pi. Pi has been told to be 3.142 from the question, then times r. R is what? 15.6. So let's simplify. So this will be 20 plus 79.6 divided by 360 times 2 times 3.142 times 15.6. This will give me 21.7. So by the time I add both ends together, this will give me 41.7 centimeter. Let's see if our answer is correct. Great. So 79.6 degree and 41.7 centimeter. Question 8 says that a chord subtends an angle of 72 degrees at the center of the circle. Find the length of arc if the radius of the circle is 3.5 centimeter. Take pi to be 20 over 7. I know that is something that you can pause and try it out by yourself and get it, but let's solve it together. I'm not going to draw the diagram because I know that you already have a pictorial view of the diagram. So the length of arc is going to be what? Theta over 360 times 2 pi r. Our theta here is 72 over 360 times 2 times pi is 22 over 7, and then our r is 3.5. So let's solve this. So from here, my length of arc is 4.4 centimeter. Let's see if we're correct. That will be option C. Great. Question 9 says that find the angle at which an arc of length 22 centimeter subtends at the center of a circle of radius 15 centimeter. Take pi to be 22 over 7. This is another question that you can pause and solve it by yourself. I'm sure you'll be able to get it. We know that the formula for length of arc is theta over 360 times 2 times pi times r. We know that the length of arc from this question is 22, so that was theta over 360 times 2 times 22 over 7 times r here is 15. 15 can go here, 15 can go here, 24. 2 here 1, 2 here 12, 2 here 6, 2 here 11. So let's cross multiply. That will be 22 times 6 times 7 is equal to 11 theta. So if I divide both sides by 11, 11 cancel 11, 11 here 1, 11 here 2. So this is 2 times 6 times 7, and this will give me 84. So our theta here is equal to 84 degrees. Let's see if we are correct. That will be option B. Great. Question 10 says that the circumference of a circular track is 9 kilometers. A cyclist rides round it a number of times and stops after covering a distance of 302 kilometers. How far is the cyclist from the starting point? This take from June 2021. I want to pause the video and try this out yourself. Welcome back. Let's look at it together. So we're told that the circumference of the circle is 9 kilometers. So that means round the circle, the length round is 9 kilometers. And he's rounding round it a number of times and stops after a distance of 302. So let's see how many times it has gone round. So 302 divided by 9. This will give me 33 and 5 point something. So he has gone round 33 times, right? So he was on his 34th ride. So it was on 34th ride. Let's see how many distance we have covered with this 33. So that was 33 times 9. So he had covered the total distance. So at, let me just say, after 33 rides, he has covered the distance of 33 times 9, right? 33 times 9, which gave me 297 kilometers. So it was on the last one. If you add 9 to 297, you see that the answer is 306. So he has not completed the last one. It now says how far is he from the starting point. So he has covered 297 round. Let's say he has gone round. Let's say this was the starting point. He had gone round 33 times and it was already here. So it was continuing. So 298, 299, 290. So until he reached the point of, let me just say, 302 kilometers. So how far is it from the starting point? So we know that at this point, say at the point of the 33 ride, he has covered 297 kilometers, right? So the difference in the two will just be how far he has actually cycled from the starting point. So that is 302 minus 297, and that's 5 kilometers. So he has covered 5 kilometers from the starting point after the 33rd round, right? Because they said they had done 302. 302 divided by 9 gave me 33 point something. I don't know the whole number part, just 33 times. I was on the 34th ride, right? So on the 34th ride, they already covered only a distance of 5 kilometers out of the total 9 kilometers, and that will be our answer. That will be option A. Great. Question 11 now says that the diagram POQ is 150 degrees and the radius of the circle PSQR is 4.2 centimeter. What is the length of the minor arc? This is taken from June 2020, so I'm sure you can pause the video and solve this yourself. But let's look at it together. I encourage you to actually pause the video though. So the length of arc, like we all said, is going to be over 360 times 2 pi r. Before we continue, if you have not liked the video and subscribed to our channel, you are very wrong. Please try to do that now. So the length of arc is what we're looking for. Our theta is 150 all over 360 times 2 times pi is 22/7 from the question. Then the r is what? 4.2. So this can cancel this. 2 here 1, 2 here 18, 2 here 9, 2 here 11. 7 can go here, that will give me 0.6. 3 can go here, that will be 0.2. 3 here 3, 3 here 1, 3 here 5. Great. So what will be left to be 5 times 11 times 0.2, and that will give me 11. So the length of my minor arc is 11 centimeter. Let's see if you are correct. That will be option A. Great. So with this, we've come to the end of our past questions on length and perimeters, covering anything about circle, length of arc, length of segments, length of chord, all those things, perimeter of a segment, perimeter of a chord. Once again, if you have not watched the video before this, where we talked about all of that in depth, I encourage you to actually do so. Look at the playlist in the description and follow through with the video before this. I'll see you guys in the next video. Bye for now.